Now, Simscale doesn't know anything about the physics of my problem, really. So it has a default mesh, right? It'll create a mesh like automatically for you. Now, when it's trying to create the mesh, if it doesn't know anything else, like you haven't told it anything else, it's going to try to create all the elements approximately the same size if it can, subject to the constraint that however it designs the elements, they have to follow whatever the geometry of your solid model was. Thank you, motorcycle. Yeah, so it's going to design a mesh that basically follows your geometry and tries to make the equally sized elements as best as possible with, quote, a good shape, which usually means like a tetrahedron, like equilateral tetrahedrons are the optimal shape if you're using tetrahedral shaped elements, so like triangles. So that's what it's going to try and do. Now, how big it makes them, if you're using the default mesher, it's going to create those triangular or tetrahedral elements. It'll use an automatic sizing algorithm, and it's got a little slider here that allows you to gain some level of control over the size. Now, how does it take the number 5 for the slider and turn that into the actual size of the element? I have no idea how this algorithm is actually working under the hood. That's why I actually recommend to use the manual button here. So when you click manual, you can actually specify the maximum edge length that you'd like your elements to be. So like if I wanted 1 meter elements, I would choose 1 meter there to be the biggest elements. The smallest edge length by default is 0. It'll make as small as it needs in order to actually follow your geometry. You can try to coax it into using something bigger when possible if you want to. I generally actually like to let it try to follow the geometry. Most of the time it won't create one that is actually 0 sized. Let's see, what else is... So before I talk about automatic mesh sweeping, let me talk about some other things. So obviously, like the number of processors, there's like an automatic button, and then again, you can try and coax it to use more processors if you want this, if you think this is going to be a long process. If you're just trying to generate, like tens of thousands of elements, that's generally going to happen very fast. So don't worry about the number of processors. There is a tab that says Advanced Settings. These are not advanced settings. These are actually very basic, I would say required settings. So let me talk about the 3 things that are down here. Not all of these actually apply to the current simulation, but I'll discuss what they are. So small feature suppression refers to like how well the elements have to follow your geometry. So it's going to try to make elements that actually replicate your solid model, not surprisingly. That means that if I have really tiny features, imagine that I created a little bump on the surface, maybe that represents a circuit component. It's going to actually try to fill that element with, that solid with elements. Presumably with a relative level of fineness, so you'll probably have more than one element inside of that volume. So, if you don't tell it otherwise, it's gonna it can make things that are as small as nanometers. Even though my total domain here is 10 meters across. So obviously, if that happens, I'm gonna end up potentially with billions of elements. I don't want that. So sometimes you can get it to ignore really tiny things that are meaningless, like geometric features, by just setting your geometric, a small feature suppression to a certain size. I don't have any of those small features in this model, so I can't really show it doing that for you. But this, if you find it creating very tiny features, you can often get it to get rid of that by setting this. Let me go to the bottom one next. This one's a really interesting one. So the global gradation rate refers to how long an element is that is adjacent to another element. So basically it's how quickly your elements grow compared to one another. So 1.22 means that the element can grow in length by up to 22%, meaning that every 5 elements approximately, the size of your elements can double. So I personally think that's a little bit fast, but that is the default. You can use your judgment. But you can reset this. So like if I set this to 1.1, that would correspond to a 10% growth rate, which is a little bit slower. The gap refinement factor doesn't apply to this model because I don't have a situation like this. But let's see if I can. I don't think I can actually zoom into this. But if I click on the side of it, it shows me a picture of what it is. So it's basically like the minimum number of elements that I would like to span a thin gap. So like if I have a thin solid somewhere, this is how many elements are going to be across that solid. So if I type in 4, that'll which is approximately what's in this picture, there'll be 4 elements that fill in like a very thin member. The flip side of that is if I put in 0.25, that'll mean that it'll fill it with just 1 element across the gap, but it'll have an aspect ratio of 4:1, meaning that the element can be fairly elongated compared to the thickness. Generally, I wouldn't recommend creating elements that have an aspect ratio of more than about 20:1 because it can cause some numerical instabilities. But you can control that all with this gap refinement factor. Now, in this simulation, I don't have any gaps. So I don't have any thin members that I have to control this for. So it doesn't really mean anything. Okay, so if you want to, you can see what this does. So if I click save, oops. So save it just saves the algorithm for how it's going to create the mesh. But to create the mesh, you actually have to click the generate button. So when you click generate, that's going to send it. So generating a mesh is fairly computationally expensive. So when you click generate, it sends it off to the computer cluster to do that calculation. And it may take some time before it comes back with a finished solution. So I'll come back to this video once it actually finishes doing that.